Hello, everybody. I'm going to talk a little bit about demystifying AI and what it actually is, and with the nice Dr. Strangelove quote, "Orwell to stop worrying and love the LLM." So everybody of us is talking about AI and LLMs and much of that. So I'm going to open up that box a little bit. Warning, there will be a little bit of math. And there will be a test in the end, of course, as is for any university lecture. You have to have that. So a little bit of what we're going to do. Who am I? A little bit of AI, a little bit about the types of AI / machine learning, and how do we actually work, and what does this mean to all of you? Going into who am I? I'm actually a biologist. I'm not an IT guy. I jumped from the field of biology to IT because I was sitting in a closet in the university doing data cleaning, doing data processing and all of this stuff, and deciding that nobody's ever going to pay me enough to do this whole data janitor stuff. And here I am still doing the same stuff 15 years later, basically on IT sector, but not just doing the biology side. Worked a lot with the AI tools and doing stuff around AI and testing. And I think that's one key point that happens with AI now, is because we can generate so much code, testing is actually going to become the number one thing that has been for a long time the second thing, and the first one that we typically take savings from. Hey, let's not test as much. But now, because it's so easy to generate code, that's going to happen a lot. And now we can get to the AI part of it as well. AI everywhere. Everybody's talking about it every single moment. How do we get there? How is everything going to change? I didn't think everything is going to change. This change has already been going on for the last 60 years, maybe. And I think this is one of the points that I'm trying to make to prove that. This is a prepackaged food from Finland. It's levolota, so it's liver casserole, pretty much. This was my first AI project that I did 15 years ago on building AI-optimized recipes for creating a liver casserole at scale in these huge factories that exists 15 years ago. And exactly the same kind of problems with neural nets, optimizing recipes and all of that. So this is not new. This has been going on for a long time, but now it feels like it's all exploding just right now. And as I said, neural networks are 70 years old. We invented all of this technology 70 years ago. Why is it happening now? And we're using this technology that is really old, and everything's changing in a really fast pace right now. And I think it's just because it's in base of it's just math. How these things work, it's not really anything super complex, or let's say complicated, but it gets complex because of the size of these things. So because of all of this evolution that's been happening with all of the math and vectors, that's all that is. It's just doing matrix multiplication. AI does nothing else than matrix multiplication. That's it. And for some reason, that gives us very good and powerful results on predicting text, predicting recipes, predicting a lot of other things, just doing this. And this is, I think, one of the key points that I want to make is it's just math. It just works. But you have to understand that it's just math. It doesn't do any kind of reasoning. It doesn't think. It doesn't do anything like that. And with these caveats, the reason why we think it's now exploding is because we as humans are really bad at forecasting exponential change. And most of the stuff that's happening in the society is exponential. But when we think about, when is AI going to change our way of life? Okay, I think in linear way, maybe in 10 years. When is fusion power going to come? In the next 15 years. When is something happening? It's always like in the linear way that we are thinking about it. But then suddenly it explodes and we get all the benefits of it. That's just because the way that change is typically exponential. You build on top of change, build on top of that, and keep going at it. And this is also reflected in a lot of the technology behind AI. These are from GitHub on the different libraries. This is what Kelsey was talking a little bit at the morning, how many stars his libraries have gotten. I got 4,000 stars. This is the history of many of the libraries used in machine learning and AI. And you can see the same kind of exponential growth in here. Looking at some of the earliest ones, MongoDB databases used for AI, slow growth, also a little bit exponential. Then you jump into Spark, you jump into all of these libraries, you see that they're growing faster and faster and faster. And then we get into transformers. This is what basically all of our AI is now based on this kind of architecture and these libraries. And it's just skyrocketing because it's built on top of all of these other changes as well. And this this is the architecture. This is what all of our AI works on. This stack of boxes. But why? And it's been working like this for 60 years. And I think the biggest reasons that this has been happening now is the soup of more compute. We build more and more computers. NVIDIA is selling like hotcakes now. That pretty much sold out for like 2 or 3 years on everything. Everybody wants more compute. One is that the architecture. We invented all of this stuff like Kubernetes, all of these kind of technologies enabling us to build on scale, enabling us to just take something off the shelf and suddenly deploy it to 1,000 machines. And also this open source community on building on top of other ideas and fast idea share. And boring continuous work from the 60s. And we've ended up here into this very Google-esque one text box user interface. We keep getting back into the basics of just having like one text box as the user interface, and then it just works. Asking it questions on what's going on, what's going to happen, what are we actually going to get? Help me study. Tell me a fun fact. Very simple user experience. It's not like some big company box product, millions of different views. Very simple. And it's all because the LLM in the background. And you can get a lot of these LLMs. There's a lot of discussion now. Can I use DeepSeek? Can I use Azure? Can I use ChatGPT? Who can I use? What's the like limitations there? Which is best? I don't think the model matters that much, because that already all the models are commoditized. There's the same kind of communities around there where you can get multiple different models and they're changed. But what does matter is the infrastructure around those models. And this is something that I think we need to take into consideration when you're thinking about where do you actually run your AI. Are you taking the whole application from OpenAI? Are you taking the whole application from Azure? Are you taking the whole application from DeepSeek in China? Because all of the data is going to go somewhere and your data lives somewhere. And that data is at its core of how we trained all of these AI models. A little bit of history. Most of the data that's being used to train all the English-speaking LLMs is pretty much stolen from the internet. Reddit being, I think, #1 source of most of the natural language data that they got. If you think about it, Reddit data is pretty much on prime for training AI. You have contextual data. All of the discussions relate to some topic, here being some gaming topics or something else. I don't even remember. Hopefully it's not too offensive or anything, but like, so then you get plus or minus context, upvotes, downvotes. Is this relevant to the topic? And a huge amount of textual data. And this is the #1 reason why Reddit also now realized that they've been giving this away for free. Their APIs were open till, I think, 2 years ago, when they realized that, hey, we can actually get a lot of money by just selling access to all of this conversational data. And they closed it down. But all of this is based on a lot of these open source, well, not open source, but open data that's been collected from multiple places. And this basically tells you what the LLM has learned. So we basically trained all of your businesses now who are using OpenAI, ChatGPT, all of this on Reddit data. So that might explain some of the curiosities that you get from it. And I'm going to talk a little bit about as well on the differences to a little bit go deeper on the tech side. What's supervised learning and unsupervised learning? This is something that has happened in the math field as well, and a lot of other fields. Is that the example here is what we are now, are we teaching the AI model what we want to predict or how we understand the world? Typical classical models typically do the first one, that we do supervised learning. We tell that this point in data is an accident. Here you can see that the traffic accident is happening. But on the case of these new AI models, you just give it a huge amount of data and you don't predict the accidents. You predict the traffic, and from there you can figure out what happens in the patterns and where there are risks. Where do you typically have more accidents on average? But you cannot predict a single accident from all the data. And this is also I'm just jumping a little bit. This might sound like I'm jumping, but many of these points I want to make so that when you use an AI, you can kind of understand that it doesn't think. It has just been thought different things, and then it infers from those, and you'll get the best average results always, which just happens to be quite good, which maybe tells something about our businesses as well and the way that we do anything if the average result is quite good. And this data is then fed into something called a generative pre-trained transformer. which is the technological word that's happening in an LLM. It's basically just splitting words into tokens. Any one of you hear tokens, I'm just gauging how technical we are here. No tokens here. A couple of them, no. Okay. So the idea with all of the LLMs, they're just glorified text prediction on your mobile. That's all the whole LLM is. They break down the text that you input them, like your question, hey, can you tell me what's the temperature like typically in London? It breaks it down into tokens, the small bits of word that we have, and then feeds this one token at a time to the AI engine that we have. And the only thing that it does, it tries to predict the next token over and over and over and over and over again. And it's nothing else than a glorified text prediction engine. And what's behind that is basically how we've trained it with all the data. Is we teach it relations between words. This is what many sometimes hear that, hey, we can embed your data into the AI. This is what we're talking about. We are teaching it relevance between different words. For example, here, this is totally arbitrary. I just, for the sake of example, we take the cat. It has something between -1 and 1 of relevance, for example. Well, it's a 0.6 living being, according to the AI for some reason. And house is -0.8, probably because it has a little bit of relation that people also live in a house. So these kind of values are assigned to different words, different tokens that's happening in here. And based on these, we can make predictions, or you can map them. For example, if you look at on the bottom of the image, you have the man and woman and king and queen. They're totally different on the wording, but the relationship or the position is different for all of them. But the relationship between man and a woman and a king and a queen on that picture is pretty much the same. And you can do this with a lot of the data that's been taught to LLMs. You can do this for, let's say, interesting wording pairs. You could take, what could be a good example? Some like the presidents of Sweden or king of Sweden and the president of Finland. You'd probably get a little bit of a similar kind of relationship that you get, and you could map from these to another. And then, well, something that's also happening if you take, for example, Mussolini and then you take Churchill, for example, you typically get probably a similar kind of a relationship between them that you can predict that these somehow relate to each other, they somehow relate to World War II and at the same time period. So for the AI, there's similar kind of difference than on the lower image. And this is what it all is basically based on. You have huge matrices, over 1 billion lines, over 1 billion, billion times 1 billion tables pretty much of these different kind of embeddings that have different weights and biases. And that's it. And then we just basically run matrix multiplication over all of these values. What is relevant to what, and predict the next token. And that's all these very great AI systems do. And understanding this, I think, gives the baseline of that. You cannot expect it to give you out-of-the-box answers because it's always based on just probability on what humans have actually inputted to the system. And it's actually quite simple for you to do as well. For if any of you are coders, then it's simple to just teach your own. It's just requires a lot of resources. You can find tutorials of building your own AI at some point. And again, we come back to the text box. So, and also this is why we have a lot of this kind of racism, why we have a lot of these kind of relevances in a lot of these AI models is because we've taught that. It's learned from the data that we have. It's kind of like a child who doesn't have any filter on its output. It's just the relevances from the data that we've given it. It's kind of a same problem like this. If I tell you do not think of a pink elephant, you always have to first think about it and then start processing, do I actually want to say it out loud? You have to understand the context around it. But now with these kind of unfiltered LLMs, this kind of a thing doesn't happen. Do not think of a pink elephant. Okay, I will not think of a pink elephant. I've already thought about it. And this is from psychology. So jumping straight from math to psychology, this is what happens with the LLM talks. So this is how humans pretty much think and operate, that we have some data on the bottom line, that we've learned something. We select some of this data based on our context, on our assumptions, on our values. We paraphrased somehow because we don't remember all of it, we've forgotten parts of it, and we have some subset of knowledge that we use. Then we probably give it the name of what's happening and then can explain it, and then decide what to do. And in each part of these, there happens some kind of filtering. And we do this daily on pretty much every single interaction that we have. For example, I could, with interacting with pretty much anybody, for example, Kalle here, I have a background with Kalle. I can say to him that, I don't know, what could be, let's go have lunch now. And that could be interpreted nicely. But if I said to you, let's go have lunch now, the experience is totally different because we are processing on two sides of it and the discussion. And this is because we do a lot of this filtering that AI doesn't do. And this is something that will help you learn a lot around how do we do this prompting, because there is no filtering. If you want to get the best bang for your buck from any of the kind of AI that you're using, be it ChatGPT or be it anything else, or be it on Azure, you really have to think about how to prompt. But we also daily prompt other humans as well. It's about how we output what we want to get done, how I form my questions, how do I explain what needs to be done. It's not just about writing a question in there, but really thinking about what needs to be done. And this, I think, is going to be the big thing in all of software engineering and all of the future of software engineering is pretty much going to be how can we eloquently tell what I want in a way that the AI system understands it, with all the different weights and biases and context and all of that I have in my head that cannot fit in one sentence for ChatGPT. And summarizing a lot of this is exactly that. Because of the way that we taught that it's just math, there's a lot of hidden biases. We don't know all the data. There's so much of the data that's been used to train these big models. We don't know what's in there. So AI is really bad on asking questions about ethical considerations and bias, because that's built in already. It already has a lot of bias. But asking these kind of questions just doesn't work. Handling complex logic and custom algorithms. This is more to do with the fact that you cannot ask it to calculate 1 plus 1 or 2 plus 3. Or maybe those you get right answer, because if you think about it, it's just probability. You'll find a lot of data in the internet saying that 1 plus 1 is 2. So it's probably going to get that right. But if you ask it 377 times 2 divided by 6, and then let's just add pi for 1, doesn't give you a right answer, because that example probably doesn't exist anywhere on the data that I did give it. So math, stuff like that, doesn't work. Rapid changes. Because we've used a lot of the data from internet, there's a lot of history behind that. You cannot rapidly change what it outputs or without training a new model. And that's why we see this cycle of getting a new model every half a year. You can train something on top of it, but you cannot change the whole model immediately. Or you maybe do some crude filtering on top that every time Trump is mentioned, just drop the whole thing, for example. You can do that, but you cannot change the underlying model easily. Security policies, asking the limit that, hey, you cannot tell this to these and these people, doesn't again work, because then we'd have to build something on top of AI to limit who gets what kind of answers. And the last one I think is controversial, creative and innovative thinking. We can generate a lot of images, we can generate art, we can generate music, we can generate all of this. But it's always based on what data have we learned and what have we given it. Of course, then it becomes that, hey, I've listened to music for whole of my life, I want to make a new song. Is my song also based on all that I've heard during my life? And is it just the same thing or not? And very different, kind of like a philosophical question. And exactly this comes down to how do you address the AI on this? That a lot of the stuff that we see, people experiment first. Hey, can you please fix my code? Okay, what piece of code do you mean? What do you want fixed? What's a positive end result? What do I actually want to fix? So talking to these systems, expanding a lot on what you actually want to get done. Here's a snippet of my code that doesn't work. No. Very expansive based on how do you actually talk to this. This is same thing that I can talk to humans. Kalle, fix my code. He doesn't know any context on what's actually happening, but explaining a lot more on, hey, it's in this repository, I have this problem, here's the error messages, can you help me with this? But because LLMs are trained on human data, that they respond to pretty much the same cues as humans as well. So the same stuff also works when working with your colleagues, explaining, expanding, and asking nicely. Actually, asking nicely works with LLMs too. You get better answers statistically by asking nicely, which is fun. And exactly, start simple, and then expand on that. Avoid impreciseness. Define how do you want it to output. You can do a lot of this stuff and get really nice outputs out of your AI. And summarizing, writing a podcast, just giving the kind of a style and just expanding on what do you actually want to. And here's a couple of just examples, long text. I'm not going to speak through them, but you can check them. Exactly, expanding and explaining to the AI what do you want to helps a lot. And exactly this that I want to talk a little bit about is now we're talking about models, but then we can build systems, and every single one, OpenAI, ChatGPT, Azure, all of these, that Gemini, all of you have been using. It's not just a model; it's a system built on top of it. I said the model is just math. The app and the stuff around it is about how they handle data inside. They typically do some kind of filtering example, for example, removing racist content or something like that, or that they identify that, hey, this is actually a math question. We can handle this with normal kind of like computers much more easily than just using an LLM for it. And also the fact that because these models are safe, the ecosystems might not be. Case in point, for example, being talked a lot about security issues is DeepSeek. So that the Chinese company released their new model, which is actually quite a good model. It's just weights and biases. But there were a lot of security issues with the app that you could get from the App Store to use that model. And that app leaked data like a sieve, pretty much. And I think the database was open in the internet at one point, so anybody could access what everybody else had been asking. But that's not the fault of the model. It's around all the tech that's built around it. And ecosystems might not be safe. So that's where I think most of the focus will now go on when you do AI. Is about how you handle that data, how you talk to your teams, how do you give access to different data for that model if you train. Do you do multiple models? Do you, in your company, basically dump all data into one bucket and anybody can query the emails of the board, for example? Probably not a good idea. Exactly this, that when you're doing safety critical work, this is even more important to understand. I've seen companies that have like Microsoft Office and the LLMs enabled on top of that, even doing safety critical systems. And then you can access that data from other clients. So really figuring out what your data architecture is. And something that's called RAG is that you can put your own data for the LLM to access, or the agents to access as well. Or be it on a cloud or on-prem, you can do both. And how do you expand on this? A lot of tech. Basically creating your own database on top of that and helping the LLM answer from that. So you can put your own data in. And then you're not just relying on the Reddit trained stuff. You get your own data on top of it, and probably you'll get better answers because it has your context and not just giving you the industry average answers based on what has been learned on the base model. So this is why systems are a lot more important than what model are you using in your stuff. Models can be changed. Models are already pretty much standardized on their output and input, so you can just drop in, replace them if you want to. But the system around that needs still effort to build and store. And this is actually something that relates to this, that then when you start using these systems, you are actually detached from the output even more. That you are not anymore just writing your code, but you're writing a prompt to an AI which creates code, or which creates your PowerPoints, or which creates your emails. And kind of like understanding that this is based on all the material that's been trained on it. And there's a very good blog by Henri Terho about this, that it's basically not about doing your work, but managing your AI team at this point in the same way that do my AI agents do what I think they do. And still developing AI solutions or having them as part of your process, totally different processes. Typically, like you have math and probability when you do your own AI, you shouldn't probably do your own AI. There's a lot of nice ones available. You should still focus on what you typically do, revenue, quality, focus. And it's not just for software development, it's for a lot of other people as well. For example, this is a typical software value stream. You have a lot of stuff in here, but this small part is where the coding happens. All this other stuff is something that's outside of code. It's what we do. You have on the left you have a work ticket, which then ends up a feature. There's huge amount of other stuff that happens between the actual value being delivered, and this is where you can use AI in a lot of other places than just code. And of course, being super important to handle the lot of randomness that acts on you. It's kind of like area that everybody uses it, might use the equipment wrong. Somebody might have done the equipment wrong on the layer 2. For example, bad maintenance or bad code in your systems. Or then just the way that you interact with other people impact on what we have. And these are all forces acting on the data that you have, which will probably make the system sometimes answer wrong. That's happening. You want to get rid of that and build nice systems. And how do we control this? Where is the single source of truth? Boring testing that I come back to, that I talked about in the beginning. And that's why I think that the world is going to go back to talk a lot about testing, talk a lot about how do we make sure that the AI is delivering the right things, and not about do we get the 10 times a code out? Can we get more code out? No, it's more about how can I explain what I want? How can I make sure that it's going to be the right stuff that's coming out of the pipeline? The speed of the pipeline in the middle doesn't matter in the future. And talk a lot about validation as well. So a lot of the fears that we see now is exactly that jobless person. Will AI replace me? Will it replace developers? I don't think so. It's going to empower, replace routine tasks so that developers focus on all the other stuff. Same fears on control and ownership. Who owns AI and software workloads? What's going to happen? We can help, what's going to happen is we can define that. We can build those kind of clear roles across the different units to help you with that. And the third fear that we've been hearing a lot is, can we trust AI in coding? Well, we already trust developers, so kind of the same thing. We have to have those control structures on top of that, build traceability, build testing around that. And I think the last one that still looks in the market, everybody's kind of looking at what's the like business case. How can I prove that AI actually delivers value? And this is like still a lot of the road mapping, still a lot of thinking about it. And how do you actually get that AI dividend out of these projects that you can then spend on some other stuff as well? So it's not just about savings, it's about getting a lot of improvements and dividends out of that improved process. And extending this automation that's happening in coding to a lot of other roles as well. It's not just about automating coding now. It's much more about automating your whole organization about it. We've done a lot of work in software about automating the way that we create coding. But now we can also, with AI, automate a lot of the soft values as well on how do we automate your business. And I think the one question that I want to, on all of this, like jumping from math to psychology to a lot of, to give some pointers that you can attach something onto on what should I focus on. And I think exactly, don't get lost on these technical points. Understand them a little bit and focus on what you actually do. How will AI help you augment what you're doing? How can you clearly explain what you're doing? Because that's going to really help you in focusing your work as well. And also just use AI tools. Everybody's going to use it. I think this is the kind of like Rubicon moment where you have to start using them to keep up with the flow, where you really have to cross that point and start using them to get in there. And you will have risk and complexity in those systems, so learn how to validate. And more code will be black box, so validate your business, and there will be more code. But the understanding that we have, or the capacity for humans to understand, is going to be about the same. That shouldn't change on what should have been done. And I think John Bosch showed something like this as well. I want to show it as well because it maps really nicely to the same thing that we were talking with John Bosch as well, that I think most of our organizations now are either in phase 1 or 2. We are nowhere near like phase 3, 4, or 5, where we are starting to automate a lot of stuff with AI. And that's going to be a big jump for organizations to build different kind of organization structures on how I am going to work with AI agents, or how we are going to handle these hybrid organizations. And I think that's going to be the most interesting time in it. Words of a Chinese proverb, may you live in interesting times. I think this is going to be one of those. Thank you.